We said that a communication could be sometimes complicated. To make this process more simple, some models have been created. So we could model a communication based on these models that we are going to explain. One of these popular models is tcp-ip. In tcp-ip, a communication would be divided into 4 different steps. As you see in here, we call each one of these steps a layer. So from top to bottom, we would have application layer, transport layer, internet layer, and network access layer. So for more simplicity, we add different set of rules or protocols in each layer that each node or device in a communication should follow to make a communication successful. For example, in the transport layer, it is for establishing a connection. The 2 main protocols in this layer are TCP or UDP. Now we want to analyze that what would happen when a packet is going to be sent from the source until it reaches the destination. Let's say that we have some data which reside on application layer. Some popular protocols for the application layer are HTTP or HTTPS. Now, if the client side wants to send this data to the other side, the packet now doesn't know anything. What is the destination address? What is the source address that this data is originating from, and other things. So it would move to the next lower layer, which is called the transport layer. In the transport layer, a header based on the protocol of TCP or UDP would be added into the data. This header contains some information for establishing a connection. In the TCP, the header would be longer because it also contains some information for error correction, so that if the packet can't get successfully to the destination, somehow the first side would be noticed and could retransmit the same packet. After that, this packet would move to the next lower layer in the internet layer. The main protocols in this layer are IPv4 or IPv6, because right now the packet, the TCP header and the data doesn't know how to be forwarded to other sites. A IP header would be added to the data that it has received from the upper layer. This header contains some information about the addresses. The source IP address and destination IP address are some information that could be added in this layer. So right now the packet has the digital addresses or IP addresses attached to it, but for a packet to be able to communicate successfully, it needs another kind of addresses which are called MAC addresses. MAC addresses are a kind of addresses which are defined as physical addresses. These addresses are written on the back of every network interface card. A network interface card or NIC has the duty for transmitting packets. So then this packet would move to the next lower layer, which is called the network access layer. Ethernet is the main protocol in this layer. So the Ethernet header containing the physical addresses of the source and destination would be added to the IP packet. Now this is a complete packet which could move and transfer from the source to the destination. After this packet gets to the destination, the NIC at the other side has accepted the packet. So in the opposite direction, the packet would move. It delivers the packet to the next higher layer. First, in this layer, the Ethernet header would be stripped away and the remaining would be delivered to the next higher layer. In this layer, after checking out the information in the IP header, the IP header would be separated and the TCP packet would be delivered to the next higher layer. In the transport layer, the same protocol or the same module, which is an implementation of the TCP protocol, would look at the same header, the TCP header, analyze the corresponding information in the TCP header, strip away this header, and deliver the data to the upper layer. Now the application layer would see the data analyze it, and could send the corresponding data to the source in the same form.